Hey you guys, I'm going to attempt to answer this question that was posed by a student on Wyzant. So the question pertains to a standing wave along a string. So it says it's the third harmonic, which means there's 3 antinodes and 2 nodes. So the length is not given. We only know that at x naught is equal to 34 centimeters, the height of the wave is at 1/2 the total amplitude. So this is the total amplitude, which we don't know and we won't really need, as you will see. So we have that at x naught, y naught is equal to 1/2 the amplitude. So we want to know what the wavelength is. So this is the variable we're looking for. And we can see from the geometry of the problem that it's 2/3 times the length, right? Because this is one wavelength right here, and then another half of a wavelength to the next node, to the end of the wave. And so that's 1 1/2 of wavelengths that are being represented on the total length of this. So we kind of are needing to know L, the length of the string, in order to be able to figure out from here what lambda is, the wavelength, which is what we're looking for. So for a standing wave, we have the general equation, y of x is equal to the amplitude. So y is in this direction, the vertical. It's given by the amplitude times 2 pi x over lambda. So we plug in here, lambda is 2/3 L. So this is equal to the total amplitude times sine 2 pi x over 2/3 L. And the 2 cancels out, and so we have that in general, we have y of x is equal to a sine of 3 pi x over L. Now we're going to use what we're given, which is that at x naught, y naught is equal to 1/2 a. So we're given that at x naught, y naught is 1/2 a. So 1/2 a is equal to a times sine of 3 pi x naught over L. Okay, so that's 3 pi x naught over L. See here, now we can cancel out the a because we can cancel it out from both sides. And taking the inverse sine of this gives us that 3 pi x naught over L is equal to inverse sine of 1/2. And so that gives us that L is equal to 3 pi x naught over inverse sine of 1/2. And what that allows us to do is to find L, but the end of the question happens when we find the wavelength, lambda. So lambda is going to be 2/3 of this, so it's 2/3 times 3 pi x naught over inverse sine of 1/2. And that, when you punch it in the calculator, lambda is equal to, plugging in 34 centimeters into x naught, you get 408 centimeters. That's the wavelength. Thanks, you guys.